given that x is equals to 3t squared plus 5t minus 10 is displacement of a particle in meters. Calculate its initial velocity. We have A, 10 meter per second, B, 2 meter per second, C, 5 meter per second, and D, 6 meter per second. This question is from the application of differentiation. So we are given that the displacement of this particle is 3t squared plus 5t minus 10, where our s is the displacement, is the displacement of the particle as given in the equation, the displacement. Then our t is the time. Of course, we were also informed that our displacement is in meter and our t is in seconds, which we already know as the SI units in this case. Now, for instantaneous velocity, the velocity is given, the initial velocity we are calculating now is given as ds over dt. That is, for us to get the velocity, it just differentiates the displacement we have been given. So I'm going to differentiate this, our displacement, with respect to t. That is why I'm writing down this, ds dt. So our velocity will be equals to, differentiating this, 3t, this is a quadratic expression, so if we differentiate this now, so 2 times 3, we have 6, then we have our t, 2 minus 1 is 1, so we have 6t for this particular one. Now the next one, we have 6t, or 5t rather. If we differentiate 5t, we have 5. The reason is this, this is t raised to power 1. So 1 times 5, we have 5. 1 times 5, we have 5. 1 minus 1, we have 0. T raised to power 0 is 1. So 5 times 1 is 5. Now the differentiation of a constant is 0. So if we differentiate this minus 10, we get 0. So no need indicating that. Okay, so this is the velocity we have been given, but we were asked to calculate its initial velocity. Now, when a body begins to move, the initial velocity of that body, at that initial velocity, we are looking at time to be 0. When the body just begins to move, at that time, the time is 0. So, for initial velocity, the time will be equals to 0. So for initial velocity, the time will be found to be 0 because the body have not started moving. At that time, the body is still at rest. So the velocity at that time, the time we are recording at that time is 0. So we substitute this into this equation. If we do that, we have our v to be equals to 6 times 0 plus 5. 6 times 0 plus 5. And 6 times 0 is 0 plus 5. And 0 plus 5 is 5. Remember, this is velocity, so velocity is meter per second. That is displacement over time. Now go to our options. When you check through the options, you find out that the correct answer, according to what we have solved so far, is option C. So that is how to solve a equation like this.